Right. Yesterday, last session, we have discussed about Ospf, right? And RIP also have discussed. RIP Ospf will comes under IGP protocol, Interior Gateway Protocol. Like IGP and EGP, Interior Gateway Protocols and Exterior Gateway Protocols. Both are what? Dynamic routing protocols. So, our main topic is we are discussing about what? Dynamic routing protocol. We already clearly discussed about difference between static routing and dynamic routing. Right? Static routes are configured, maintained, updated by network administrator manually, and no automatic updates in static routing. If any changes, manually we need to update. Right? Administrative work is more. Routing entries, routing table entries, we need to update manually. In case of dynamic routing, like automatic updates, like any changes in network topology, automatically updated, right? Like any new router is added, any network is been down, an interface is down. Like all routers will start sending updates each other. This we call automatic updates. Moreover, destination network information is not required for to configure all type of dynamic routing protocols. Only the directly connect network information is enough. So obviously, network administrator work is what? Less. Dynamic routing protocol is used to recommend to configure in medium and large network. Dynamic routing protocols are two categories. One is IGP and EGP. IGP categories: distance vector, link state, and advanced distance vector. RIP will comes under which type of protocol, guys? RIP. Which category? Distance vector or link state or advanced distance? DVP, right? Distance vector protocol is a RIP. In RIP have two versions, RIP version 1 and version 2. What's the difference between version 1 and version 2? RIP version 1 and version 2. What's the difference, guys? RIP version 1 is a classful routing protocol. RIP version 2 is classless routing protocol. Classful and classless. Classful is it is not support for subnetting, and classless is support for subnetting. Okay. Right. IGRP is a classful. RIP version 1 is a classful. Remaining all protocols, which is RIP version 2, OSP of EAGRP, remaining all protocols are classless routing protocol, which are support for subnetting. And RIP is a open standard which can support for multiple vendors. The classless routing protocol and RIP will find the best path based upon hop count only, number of hops. The RIP send the multicast message by using which IP address? Example here, dynamic routing. One category is IGP, one more is a distance vector protocol. Protocol is what? RIP. Now, RIP is a open standard, and RIP will send the multicast messages by using which IP address, guys? 224.0.0.9. Okay, and the metric of RIP, like how RIP will find the best path. The metric of RIP is based upon what? Hop count. So what was the maximum hop count? Maximum hop count is a 15. Like what type of updates in RIP protocol? RIP, what type of updates? Like periodically for every 30 seconds RFP will send the update. That update is also what? Complete routing table is a update for every 30 seconds. This type of updates we call periodically updates. Okay. Now, yesterday we have discussed about one more protocol which is LSP, link state protocol. In LSP, what is the L? L means what? Link. What is link? Link means what? Link is nothing but router interface. State is nothing but what? Status of the interface. The link state protocol is, actual protocol is what? OSPF, open shortest path first. OSPF also open standard. And OSPF will send the multicast messages by using which IP address, guys? 224.0.0.5. Perfect. And metric of OSPF protocol. Like how OSPF will find the best path. Like OSPF will find the best path based upon what? Bandwidth, speed. To calculate the bandwidth, Cisco, we used one formula that we call 10 to the power of 8 by bandwidth. So this formula we call it is a cost. So based upon cost, OSP will find the best path. And what was the maximum hop count of OSP protocol? Do you have any limit in a OSP protocol? No, it's support for unlimited protocol. And what is update in OSP protocol? In case of RIP, complete routing table is a update for every 30 seconds. But in case of OSPF, what is update? Like type of updates are incremental. I'm asking what is update? Like what information inside the update packet? So this update we called, I have given one technical terminology. One. Yeah, Pradeep, type of updates are incremental. I'm asking about what is update. In RIP, periodical updates. But what is update? Complete routing table is update. In case of OSPU, LSAs. LSAs is update, right? Link state advertisements, like which link is being failed. That information is only updated. LSAs. Okay. And what type of update means incremental? When update happens, when there is a change, then only update. Incremental. In RI protocol, when update is been sent, every 30 seconds, after 30 seconds. In case of OSP protocol, when see, you are getting confused. 10-second is for hello packet. Hello packet to maintain the neighbor. Hello packet is a different. Update is a different. Try to understand here. Hello packet only for what? To maintain the neighbor. Okay, when update means only when change. But when? After 10 seconds, after 5 seconds, or after 30 seconds, when? The 40 seconds is a dead interval timing, Nagseva. So when update means is a instant, exactly Rakesh. Instant update, quick updates. Very good. If link is down, can send update. But every 10 seconds exchange about what? Hello packets. Hello packets are for only for what? This very important point is this hello packet only for what purpose? Only to maintain neighbor. Like your neighbor routers are active or not. That is only. Update is different. Inside the hello packet, like we have the information we'll discuss today. But when hello packets are every 10 seconds, when updates are happen, when there is a change, incremental. And when update, quick update, quickly. These are the points you can keep in mind about OSPO, Open Standard 24005. Metric of OSPO is cost formula is 10 power 8 by bandwidth. It can support for unlimited. Update is LSA, incremental type of updates and quickly updates. OSPO router ID. First preference for router ID command manually. Second preference for highest loopback address or highest loopback interface address. Third priority, third preference for what? Highest physical interface IP. The router ID. So these are all the topics already we have discussed. So do you have any doubts regarding the state topic? Everyone is clear? And we have discussed wildcard mask, formula, global subnet mask, minus subnet mask. Like this is a class A wildcard mask, class B wildcard mask, class C wildcard mask. And configuration of OSP of router, OSP of cross ID, network ID, wildcard mask, area ID, default area ID is a 0. Like what is area? Today we'll clearly discuss about this. And verification commands like show IP route OSPF, debug IP OSPF. Hello, maybe in the packet traces software, some softwares this command will not support. Today I will give the alternate command and show IP OSPF neighbor, show IP OSPF database. All the commands verification. Today let me continue with OSPF only. Let me configure OSPF first in this router. I'll show you the OSPF configuration once again. You try to concentrate on it. Enable show IP route command. I can get 3 directly connect networks here. So by seeing this information, I can easily configure OSPF. Let me go to configuration mode. Type router OSPF. You can use any number between 1 to 65,535. So my example is 123, which is process ID. Enter network space network ID. The routing table one by one, line by line. You can use the first network is 1600. Phase and wildcard mask of this class A network is 0.255.255.255. Default area ID 0. Next network 80.0.0.0. 0.255.255.255. Area ID 0. Last network 192.168.2.0. And class C wildcard mask is 0.0.0.255. Area 0. This I'm making use N command. The branch office 1 router OSPF is being configured. Let me configure in middle router, which is head office. Enable IP route. Routing table you can see here. Configuration mode. Router OSPF 456 cross ID. Network 10.0.0.0. Wildcard mask 0.255.255.255. Default area ID 0. And second network 60. The third network 70. Let me end. So head office router configuration also done. Last router branch office 2 to IP route. Configuration mode router OSPF cross ID 789. Network 70.0.0. 0.255.255.255 dot. Area 0. One more is 80. Last network 192.168.3.0.0.255 area ID 0. Now, three routers are being configured, right? Hello, if you can hear me? All right. Now, let me check routing table. Each router, the first router, show IP route. They can get all information of that show IP route OSPO. Then you can have only OSPO of information, right? So, to reach standard network, to reach this destination, 110 by 65. Next hop is a via 6112 serial 0/0 exit point. This network is being updated by using what? Oh, OSPF information. But how we can understand clearly about this information? Today, our concept. Let me start with OSPF metric. OSPF metric. Today, our main topic. Let me start with OSPF metric. What is the OSPF metric? OSPF metric is a cost, right? OSPF metric is cost. What's the cost formula? So actually, cost formula is a to the power of 8 by bandwidth, right? But generally, we used to write like this. Cost formula is reference bandwidth by interface bandwidth. What is the reference bandwidth? Default reference bandwidth default reference bandwidth is 100. This is the point you can keep in mind, guys. Default reference bandwidth is what? 100 MB. Okay. So let me repeat once again. A cost formula. What is the cost formula? Reference bandwidth by interface bandwidth. So what is the different reference bandwidth? Reference bandwidth is what? 100 Mbps. Okay, guys. Let me open my notes. SP of metric. Right. You can see here. CSPF uses the cost as a metric. Cost formula. Reference bandwidth by interface bandwidth. Default reference bandwidth is 100 Mbps. Okay. So back to calculation here. We know about reference bandwidth. Reference bandwidth 100 Mbps. Now let me check with a interface bandwidth. Like what type of interface are available in your network? We have LAN interface, WAN interface, and LAN interface. What type of LAN interface are available? Ethernet ports, right? Okay. Next, and we have fast Ethernet ports, and finally serial interface. Right? Now let me check clearly. Ethernet. What's the speed of Ethernet, guys? Ethernet port speed. Ethernet speed is a 10 Mbps. Fast Ethernet 100 Mbps. Serial interface, no answer. Right? So we are clearly discussed about Ethernet speed and fast Ethernet speed, right? What about serial interface speed? Let me check now. Like in router, privilege mode, show interface, we use command fast Ethernet 0/0. Now I can get fast Ethernet speed 0/0. You can see here bandwidth is the here showing is a kilobits. If we convert into megabits, you can get what 100 Mbps. Like 1 lakh kilobits. Convert into megabits, you can get how many? 100 Mbps. So what was the command to check the serial interface speed? Same command. So interface, which is a fast Ethernet, you can use serial 0/0. Enter. Now serial interface bandwidth is what, guys, here? 1544 kilobit means if we convert into megabits, for the speeds 1.54 Mbps. Okay, now we got all interfaces bandwidth. Interface bandwidth is okay, and we know about a reference bandwidth also. Now let me go for the cost calculation. Cost formula. What is the cost formula? A reference bandwidth. What is the default reference bandwidth? 100 Mbps. 100 by interface bandwidth, which is Ethernet interface. Bandwidth is what, guys? 10. 100 by 10. So cost of Ethernet is what? 10. I'll go for fast Ethernet. So for fast Ethernet, reference bandwidth is, what was the reference bandwidth? The reference bandwidth is 100 by interface bandwidth also what? 100. So cost of fast Ethernet is 1. 100 by 100 is what? 1. Okay. Now let me check for serial interface. Reference bandwidth is 100 by interface bandwidth. What's the interface speed? 1.54 Mbps. If we do calculation, now I can get serial interface cost is 64. Okay, guys. So these are the OSP of cost values. Now we clearly know about what Ethernet cost is what 10. Fast Ethernet cost is what 1. Serial interface cost is what, guys? 64. Hello. Any issues here? Is my voice is clear? So let me check from my side also, and you can check from your side also. Like it's been seen someone is log in and log out. What happening? I don't know actually. From my side, I think everything is fine. Is it clear now? Right. Okay. Now Ethernet cost is what, guys? 10. Speed is 10 Mbps. Cost is 10. Fast Ethernet speed is 100 Mbps. Cost is what? 1. Serial interface speed is a 1.54 Mbps, but cost is what? 64. Here, least cost, high bandwidth. If cost is least, then you can get high speed. So cost is 1. Cost is least cost. But speed is what? 100 Mbps. If cost is high, cost is 64. But you can get speed is what? 1.54 Mbps. Always least is the best. Okay? Least half count, least cost, like this. Now let me open my network topology here. Now if you listen carefully, it is very important point here. Now R1 router, R2, R3, three routers example. R1 LAN interface is a fast Ethernet port. R2 LAN port is also fast Ethernet, and R3 LAN port is also fast Ethernet. Now R1, R2, R3 backup link, all are serial interface are being connected. Now you tell me guys, what is the cost of R1 LAN interface? R1 LAN interface cost is what? R1 LAN interface cost is what? 1. Okay, good. R2 LAN interface cost? 1. R3 LAN interface cost? 1. Why? Because all are a fast Ethernet ports. Now link between R1, R2, the WAN link, serial link, what is the cost? R1, R2 cost? WAN link is 64. Now R2, R3 is also what? 64. R1, R3 is also is what? 64. Perfect. So now you tell me guys here, from R1 LAN users to reach R2 LAN, which is standard network, and to reach R3 LAN, which is 192.168 network. The R1 LAN network is 192.168.2.0. Now from R1 LAN to reach R2, how many paths? How many paths are available? From R1 to reach R2, I can go via serial 0/0 interface, and I can go via serial 0/1 interface, right? Two paths. If I go via serial 0/0, what was the cost, guys, here? I repeat my question once again. From serial 0/0 to reach R2 LAN users, what was the cost? From R1 serial 0/0. Yes, Angita, perfect. So serial 0/0 to reach LAN means 64 is a WAN link plus R2 fast Ethernet cost is what? 1. 64 plus 1, total cost price is what? 65. Okay. Now if traffic is going via serial 0/1 to reach 10 dot network, means LAN, what was the cost? Via serial 0/1 to reach R2 LAN, what is the cost? 129. How? R1, R3, 64 plus R2, sorry, R3, R2, 64 plus R2 LAN interface is a 1. Total cost is what? 129. So to reach from R1 towards 10 dot network, what is the cost again? What was the finally cost? Which is the best one? 65 is the base or 129 is the best? 65. So means 65 means via which interface? Serial 0/0. Now if I open the routing table in R1 10.0.0, this network is being updated by which routing protocol? Ospf indicates.wo. And your close brackets, AD value of Ospf is what? 110. Out of two metrics, which is the best metric value? 65 is a best metric. Closed. The traffic is going via which interface, guys? Serial 0/0. The same information you can get in your routing table. Come to routing table and you can check here. Let me open the routing table. Show IP load. Enter. You can see here 10 dot network. OSPF is updated 110 by 65. 64 plus 165 is the cost. So traffic is going via 0/0. Okay, guys. Like exactly, we can understand how 65 is being came. The second point is here. Now R1, R2 LAN is communicating via 0/0 after some time if 0/0 link is being failed. If 0/0 is a failed, now R1, R2 can communicate. Okay, how they can communicate? Why? Because we have configured which routing protocol, dynamic routing protocol. The major advantage of dynamic routing protocol is when base route is being failed, now within a seconds, automatically finding second base route. It's going to find the second base route automatically, right? Or manually we need to configure? Automatic, right? Whenever 0/0 is being down, now traffic can go via on the interface. Now you tell me guys, if 0/0 is a fail, then the routing table, what information you can get? 10.0.0.0 is being updated by OSP of the brackets 110 by 129. Okay, via which interface guys is going via which interface? Serial 0/1, right? Via serial 0/1. Let me check now. I'm going to make a link is down. Which interface into down? Serial 0/. Let me make it configure terminal interface serial 0/0 shutdown. And this node is being down. Now back to privilege mode. If we check to IP root command routing table, you can see here 10.0.0 network 110 by 129. The traffic is going via serial 0/1. Let me check the animation. I'm taking one data packet from source to destination. Let me take one more packet. Source to destination. Success. Now see the packet how it is moving. Packet from source to switch and switch to router. And router will check the routing table. Routing table base route is 0/1 is going via 0/1 to R3, R3 to R2. The R2 routing table will check and will send the destination computer. The destination PC reply is started back. The reply also will come back in the same route, same path. Okay. Now after some time my best path is being activated. Serial 0/0 being activated, no shutdown. IP interface is protocol showing the down. Here class low. Remove one successful. Not to be inactive. Wait for some time. It automatically update it. Right. And copy this formula. Calculate the Ospf cost. Just restart the router and we'll go to back again. Continue. Meanwhile, you can copy Ospf metric. Cost formula is reference bandwidth by interface bandwidth, and the default reference bandwidth is 100 Mbps. Ethernet cost is 10, fastnet cost is 1, and interface cost is 1. Okay. The router will run and we start the simulation. Right. Now, if we check OSPO 10 dot network 65 via serial relation. Clear, guys? This is the default calculation. But my requirement is the default cost value is 64, but we can change it. This is our requirement. We can change it now. Let me change. If I change the serial 0/0 cost is default cost is what 64, but manually I have changed as 0/0 is a 128. I have changed. Now come to via serial 0/0. What was the cost value from serial 0/0 to reach LAN 10 dot LAN? What is the cost value, guys? Now, no, like I have changed now. Cost value is 128 for WAN link. Yes. Like 128 plus 1 cost is what? 129. Now what about serial 0/1 link, the backup link? So 0/1 link is a 64 plus 64 plus 1. Total cost is what? 129. So to reach 10 dot network, we have two interfaces. We have a two paths. One is 0/0, one more is 0/1. If two interfaces speed is what, cost is what? Same cost. Then out of two, which is the best one? The best one? So let's hop count. The hop count only will comes under what? RIP protocol only. Hop count will consider algorithm is only distance vector protocol. OSPF will never consider number of hops. Like OSPF will always will find the best path based on what? Cost. So 0/0 cost is 129. Even 0/1 cost is also what? 129. If both cost is same, what OSPF protocol will do? Load balancing. Both are distance. The routing table, we can get entry now. You know what information? To reach 10 dot network, 110 by 129, 110 by 129 via serial 0/0. At the same time, you can have one more information, 110 by 129 via serial 0/1. So two interfaces information you can get in the routing table for to reach one network. So what does it mean by? So it means like a traffic is going where 0/0, 0/1 means both. Load balancing happening here actually. So let me change how to change the cost value for interface. Interface serial 0/0 IP OSP of cost 128. I changed as 128. Okay. Now and command now check your routing entry, routing table, show IP routes. See here. To reach standard network, we have 129 via serial 0/0. One more metric 129 via 0/1. Here traffic is going via 0/0 and 0/1 both. Like how we can understand like how we can understand load balancing happening or not. trace route. Destination is 10001. Enter. So first packet is going via which interface, guys? 60112. Once again, if I trace route, now one more packet is going via 8112. One more time, if we trace route, next packet 60112. Next, if we trace route, one more packet is what? 8112. So one packet via 6112, one more packet via 8112, one more packet again 6112, one more packet 8112. Means both traffic is going via this interface and this interface. Load balancing is happening actually. Let's into the trace how the traffic is going. So IP route traffic is going to 6112 as well as 8112. Let me show you once again. Trace route 10.1, 6112. Again trace route 8112. Again trace route 6112. Again, if we trace route 81, and means load balancing. Okay. This is the configuration command. Ospf cost metric for interface. Interface serial number IP Ospf cost. For example, I have changed as 120. Copy. Clear? So like this, we can understand about Ospf protocol, routing table, and load balancing. What information more we need to focus on the routing table. So how 129 is came and what is the interface and voice, all about Ospf tablet. Okay, guys. Right. OSP of neighbor state. So how exactly OSP of neighbor state means? Example, router A, LAN interface IP address is 192.168.1.1, and router B, LAN interface is 10.0.0.1. Link between A and B is WAN link, serial 0/0 IP address 18.1.1, and here 18.1.1.2 is serial 0/1. Okay. Now you tell me, guys, router A routing table 192.168.1.0 is directly connected to fast Ethernet 0/0, and 18.0.0.0 is directly connected to via serial 0/0. Now B routing table 10.0.0.0, which is directly connected to via fast Ethernet 0/0, and 18 dot network 18.0.0, which is directly connected to via serial 0/1. This is a routing table. Now between A, B router, how database is being exchanged, how routing tables are exchanged, that we now clearly discuss. So this process happen in a OSP of 7 states. Let me discuss clearly about OSP of 7 states. First one is both sides, A router side and B router side. First state we called is a down state. Even B also, first state we called down. In down state, no router IDs, no hello package, no database exchange, nothing. Just OSPF is configured state, we call what? Down state. Just OSPF is implemented. Now, second state of OSPF we call initial state, init. Both sides, second state of OSPF is a initial state. In initial state, what A is doing is, hello router B, I am so and so router. Sending one message, hello B, hello neighbor B, I am so and so router. So what will be the router ID of A router? Can you tell me, guys? Router A, what will be the router ID of A router? Here, no manual router ID command is not configured. No loopbacks are not configured. So router ID should be highest physical interface IP address, right? So which is 192.168.1.1. Hello B, I am 192.168.1.1. We'll send a message. Now B will give the reply. Yeah, hello A. I am. What is the router ID of B router? 18.1.1.2. Why? Because 10 is the lowest, right? Like highest IP address is 18.1.1.2. So router IDs, these are happening in a second state which we call initial state. Now third state of OSPF is a two-way state. In two-way state, we'll send hello packets, hello messages. Hello router. Yeah, hello neighbor. I have seen your hello. Now A will come to know B is active. Okay, my neighbor is active. Now B also will come to know A is active. Okay, my neighbor is active. Now A and B become neighbors. Yeah, we become what? Neighbors. We keep on maintaining our neighbor relation. So once neighbor is being formed, now A has to extend the database, right? So before exchanging, what A is telling is that router B, wait for some time. So first I will update. So B is telling is that no, wait, you wait, I will update. Like both are deciding to exchange. So actually you need to understand this is behave in a very large network, but I'm explaining between the two routers. Now you assume in the real time what happened, number of routers starting fighting each other. I will update first, I will update first, I will update first. Then finally, who will update first? Which router will update first? They are going to decide. Routers are going to decide which router has to update first. So that state we call exchange start. But not exchanging here. Exchange is being started. Deciding to exchange. That state we call X start. Means exchange start. State number 4. Exchange X start. So finally, how to which router has been exchanging means which router has the highest router ID. That router will become master router, and remaining all are slave routers. So A router ID is 192.168.1.1. B router ID is what? 18.1.1.2 out of two routers, which is the highest router ID. A router. So router A is a master. And router B is what? Now you tell me guys, what exactly happening in fourth state of OSPF master and slave election process, right? So master and slave election process based upon what? Router IDs. So router ID, which is the highest router ID, that will be the master, right? Now router A has to be the update first. So that state we call exchange. Now exchange is started actually. The fifth state, your database exchange. Now what A is doing is have a two links information. One is fast Ethernet 0/0, serial 0/0. So take my two links information will update to B. So B is telling is that hello A already have 18 dot network information is there. Now remaining 192.160 I will update it here. It's going to update. It's going to loading in the routing table 192.168 1.0. So this network is being updated by using which routing protocol? OSPF. So your code is what? O is the code. OSPF is updated. Now B will update. So now take my links information. So what are the links information missing here? Only 10.0.0.10.0.0.0 OSPF is updated. So this state, the sixth state we call loading. OSPF loading state. Now A routing table and B routing table both are same information, right? So this state we call full state. Seventh state is a full. So this is OSP of 7 states. Down, initial, two-way, exchange start, exstart, exchange, loading, and full. OSP of something. You can copy it now. First router name is R1, R2, WAN link, serial 0/0, IP address 18.1.1.1/8, other interface 18.1.1.2/8. I decided to configure OSPF between the two routers. Now you tell me guys, what is the process of 7 states of OSPF? What is the first state? In R1, R2, what is the first state? Down state. Okay. And second state? Initial state. Router IDs will exchange. So what is the third state? State 3 is a two-way state. What exactly happens in a two-way state? Hello packs are exchanged. Router 1 will send a hello. And router 2 also will give the reply for what? But what is exactly inside the hello packet? Exchanging hello packet for every 10 seconds. What is the information inside the hello packet? HELLO hello is a. Now, let me discuss what is a hello packet content. OSPF hello packet. Like OSPF hello packet contains is a first one is area ID, and second one is a network ID. Third point is a subnet mask, and fourth point is a hello and dead timers, dead interval timers. The last one is a OSPF authentication. OSPF authentication is a optional. Authentication is optional. This is all the information hello packet contains. Area ID, network ID, subnet mask, hello timers, dead interval timers. Authentication is optional. Clear? Now let me check R1 hello packet. What is the information? Inside R1 hello. R1 hello. So what's the first information on hello? Area ID. What is the default area ID, guys? Default area ID. Area 0. Right. Area ID what? 0. Now network ID. So WAN link network ID. What is the WAN link network ID? 18.0.0.0 is the network ID. And next point is a subnet mask. What is the subnet mask of R1 router? Not wildcard mask, subnet mask. 255.0.0.0. Right? Okay, now hello timers. Ospf hello timers. 10 seconds. And dead interval timers. Dead timers are what? 40 seconds. And authentication is optional. Leave it. So this is R1 hello packet. Right, guys? R1 hello packet. Now let me check R2 hello packet. In R2 hello packet, what is the first one? Area ID. Area ID is a default area ID is a 0. And WAN link R2 WAN link network ID is what, guys? 18.0.0.0. Subnet mask 255.0.0.0. Hello timers 10. Dead timers 40. This is R2 hello packet. So these information both routers are exchanging. Hello neighbor, right? Now if you check R1 hello packet, R2 hello packet, both are same information or not? Area is matching, network ID is matching, subnet mask is matching, hello timers is matching. So when hello packet is matching, then only R1, R2 become the neighbors. So to become the neighbors, by exchanging hello package, neighbor will not become. When neighbors will become, by matching the hello packet, neighbor will form. So what should match to form the neighbor? Area ID should match. If R1 area is a 0, if R2 area is a 10, they can exchange hello packets, but hello packet is not matching. No neighbor. Okay. Like area ID should match. Area ID okay, now. Network ID. Like R1 network ID is a 1800. Now R2 area ID should be 1800. If it is a 9800, they can exchange hellos, but hello packet is not matching. Yeah, network ID should match. Similarly, subnet mask also. If it is a /8, your neighbor router also should be what? /8, 255.0.0. If R1 is /8, if R2 is a /18, subnet mask is not matching. No neighbor. And hello timer should match. So by matching hello packet, R1, R2 become neighbors. Like what should match means area ID, network ID, subnet mask, hello timers, and authentication, which is password also. Okay, guys. See the theory. Neighbor. Routers that share a common link become the neighbors. Neighbors are discovered by hello packets. To become neighbors, following should match. What should match? Area ID should match, network ID and subnet mask, hello timers and dead timers, authentication. These all should match. Even any one of the parameters is not matching, no neighbor. Okay, guys. So here we have a two terminologies. One is a neighbor and one more is a adjacencies. No neighbor means no database exchange. Communication also. Exactly, no communication. So here we have a 2 points here. One is what? Neighbor and one more is adjacencies. So what is mean by neighbor and what is mean by adjacency? Adjacencies are formed once neighbor relation is being established. So Adjacency is only database details are exchanged. So here, database information exchanged by neighbor or adjacencies. So database details are exchanged by what? Adjacency. When adjacency has been formed, once neighbor relation has been established. Example, let me draw on diagram here. R1 router, R2, R3, and R4. R1, R2 directly connected. R1, R3 is directly connected. R1, R4 is directly connected. Now for R1 router, which routers are neighbor routers, guys? For R1, which routers are neighbor routers? R2, R3, R4 is neighbor routers, right? Okay, why? Because all R2, R3, R4 is are directly connected. I have configured OSPF between all routers. Now R1 exchanging hello packet. R2 also gives a reply. Now hello packet is matching. Hello packet is same for R1, R2. Now R1, R3 hellos are being exchanged. And hello packet is also matching between R1, R3. R1, R4, they exchange hello packets, but hello packets are not matching. Now you tell me, guys, for R1 router, which routers are neighbor routers? For R1 router, R2, R3, R4 is also neighbor. See, R4 is directly connected, right? Directly connected means is a neighbor. Safa? Mike? Safa?
ఈరోజు పొద్దు పోతాడు చూసాను నేను హెవీగా ఉంది కొన్ని కొన్ని రోజులు పోయట్లా
Hello, Mustafa? Right. Can you hear me, all of you? Here, which routers are neighbor means R2 is neighbor, R3 is neighbor, R4 is also neighbor. Because three routers are directly connected. But which routers are hello packets are matching? R1, R2 hello packet, R1, R3 hello packet is matching means R1, R2 become neighbor and adjacency also. R1, R3 become neighbor come adjacency, but R1, R4 only the neighbor is not adjacency. R1 will exchange the database information to which routers? So which are neighbor come adjacency. So for those routers only database is exchanged, which is R21, R3, but R4 is also a neighbor because directly connected, right? So now you can clear what is a neighbor, what is adjacency. It means successful neighbor is adjacency in simple word you can call it. See, R1, R4 directly connected, they're exchanging hello packets, but hello packet is not matching means doesn't mean what R4 is not a neighbor. No, we can't say like that. R4 is neighbor, but thing is what is not adjacency. Next terminology is OSP of tables. Let me discuss OSP of tables. Let us give the name for these routers. Router A, router B, router C, router D, E, F, G, and H. For A router, which routers are directly connected? Which routers are neighbor routers? B, C, D is a neighbor, right? From B to reach H, you have one link. You have one more link is there. One more link is there. My link S0, S1. Two links are available. From C router, one link, one more link, one more link. S0, S1, S2, serial 2. From D, 1, 2, 3 links. S0, S1, S2. This is the topology now. Like any router series you can use. Not only 200 series, you can use any router series. Because of port number 0/0, it could be a 2600 routers only. If it's 2800, we can get the serial numbers are 0/0/0 30. Port numbers, no problem. Okay, see the main point is here. Ospf tables. So Ospf tables maintains three type of tables. The first one is neighbor table. One more is a database table. The last one is routing table. Tables. Ospf tables are three: neighbor, database, routing table. Now let me clearly discuss what is the neighbor table contains and what is the database table contains and what is routing table contains. Now in A router, in network diagram, complete network diagram here configured protocol is what? Ospf. Like once Ospf is been configured, now A will start hello path, right? Hello neighbor B. If neighbor B give the reply, yes, hello A. If hello is matching, now A and B become what? They have exchanged hellos and hellos is matching. Now A and B router become what, guys? Neighbor come adjacencies, right? Now B information will be updated here. B is my neighbor come adjacency. Right. We'll give thanks, acknowledgement. Thanks for your reply. Now one more. You are my neighbor C. Hello neighbor C. Please give the reply. Now hello is matching. Now A and C become the neighbor come adjacencies. Okay, is updated to neighbor table. C is you are my neighbor. And is sending update hello packet to D. D is replied, but hello is not matching. So D information will not update to in neighbor table. The neighbor table contains directly connected neighbors neighbor becoming what? Adjacency. If even A and D hello packet is matching, then D also will be updated, right? So D also updated. So Ospf neighbor table contains directly connected neighbors become adjacencies information. Now what A is doing is, like A router always will depends upon neighbor routers to reach the H router, to reach E router, to reach F router, to reach G router, to reach branch office 3, to reach branch office 4. Like any branches, A router will be depends upon what? Neighbor routers only. So which is very important terminology you try to understand, guys, in the real time. If your company router will not calculate it interior throughout the destination, so what your office router will do, which routers are neighbor routers, your router will depends upon what? Neighbors information only. So A is going to ask the B, Hello B, I'm trying to reach H router. I'm trying to reach what? H. My destination is H. So B router, you tell me how many routes are available from B. So B is telling is that yes, A have zero, S0 and S1 have two paths are available. So B is going to update to A have two links. So link 1 is serial 0, link 2 is 0 slash serial 1 have a two links information. What A is doing is the two links information will be updating database table which is serial 0 and serial 1 via B router is updated. Now we'll send the acknowledgement. Thanks for update. Fine. So what A is doing is, so B, you not only my neighbors, still you have a two more neighbors. Let me inquiry. Let me check with my other two neighbors also. Sending the message to B or C. Hello C, I'm trying to reach H. In general, let me tell you one example. Generally, if you want to reach somewhere, which is we don't you if you don't know, from Hyderabad, I'm trying to reach Vijayawada. I need to go for Vijayawada. So what I'm doing is I lost my friends. I make a phone call. Hello, friend. Can you please tell me what is the best path? What is the best route to reach Vijayawada? So I have a 5 to 6 friends. I'll call you only one friend. I can take the decision only based depends upon only one person. No. Generally, what we'll do, we'll make a 2 3 persons. Like based upon the 2 3% information, finally we can decide. Okay, one is the best route, right? So my close friends are 3 members. Then what I do, I make a phone call to first friend. Hello, I'm planning to reach. I'm planning to reach Vijayawada. What is the best? So one of the person is telling is that you go to Shamshabad, then get your flight, and you can go like this, Gannavaram, something like. And I make a phone call to another person. He's telling is that no, you directly go to like MGB's bus stand, and you can cash any like super luxury or any Garuda plus something. Like one of the friend my I call and he's telling is that so and sometime we have very super fast train is there. You can catch it. You can reach early. So I'm collecting all the information. So based on that information, I can choose what any one of the best, right? Same thing like that. What A is doing is going to collect all the information from the neighbors. Similarly, C router. Hello, C router. I'm trying to reach H router. You tell me how many routes are available, how many paths are available. So C is telling that yes, A router have link serial 0, serial 1, serial 2. Three links are available. Update to A. So what A is doing is going to update in database table. It's going to store in database table serial 0, serial 1, and serial 2 via C neighbor. Send the message. Thanks. Again, make phone call to another friend, right? Like a is going to send a message to neighbor D because in my neighbor D is what you have update. Neighbor table. Neighbor table, serial 0, serial 1, serial 2 via D. So based on this information, what I'm doing is I'm running SPF algorithm. This is YSPF algorithm. So by using SPF algorithm, out of these all paths, I can decide any one of the path is best. Like A to B, B to 0, 1, or A to C, C to S1, or A to D, D to S1 or S0, something, any one. So that best path will be shifted to routing table. The routing table always contain best path. Clear, guys? So from A LAN users to reach H LAN users, which route they can choose? Based upon which information? Based upon routing table information or based upon database table information or neighbor table information? Your traffic can reach via always via which table information, guys? Table. So what is the neighbor table contains information? OSP of neighbor table contains information about directly connected routers, is forming neighbor cum adjacency. And OSP of database table contains information about what now? OSP of database table contains, like, from source to destination, all possible routes or available paths. Can go via A to B, B to 0, serial 0, B to serial 1, C to S0, serial to S1, S2, like all possible, like entire view of the topology. What is OSP of, like, what is the routing table contains? Only the best route. So here you need to understand very important point is, in your companies, in your organization, let's say I'm working for office ABC in Hyderabad location. This is my router. So for this router, how many routers are neighbor routers? How we can come to know? For office ABC Hyderabad router, for this router, which routers are neighbor routers? How we can check it? Yes, please. So for A router, how many are neighbors? How we can check? Open which table is A? Open your neighbor table, you can get information, right? Log into router A, log into your office router, and check your neighbor table. You can get how many routers are neighbors. So from your router, your organization router, how many possible paths are available? Like, what is the entire view of the topology? Like all possible routes information to get. How we can get it? Database table. Like if you log into router and check the database table, now you can come to know all possible routes information, right? Okay, good. But from your office, your employees traffic, your end users traffic to reach your destination via which route your traffic is going, how we can check it. Perfect. Routing table. So if you open the routing table, by seeing the routing table information, we can come to know your traffic is going via which route. Right? Clear, guys? So these all are OSP of tables. OSP of tables. It maintains the three tables: neighbor table, database table, and routing table. Neighbor table contains information about directly connected neighbors forming adjacency. Database table contains information about the entire view of the topology with respect to each router. OSP of routing table contains information about best path. Okay, clear? Let me continue our terminology. Let's see. L means what, guys? We already discussed yesterday. Link is nothing but what? Router. State. S is state. Description of interface. And neighbor relation. Sending to the neighbor router. Description of interface means the router interface state is a up, down, is an initial state, it is a two-way state. What is the status of information? What is the status of exactly? The information is being sending to the neighbor router. Right? Now you tell me, guys, what type of updates in OSPF? Generally, OSPF update types are what? In OSPF, do you have a periodical updates or incremental updates? I'm asking about incremental. Incremental update means what? Whenever there is a change in topology, then only update. If there is no changes, you have updates. No. Right? Okay. So in R1 router, R2 router, R3, R4, R5, some network uses. So between all routers, I configured OSPF. By what's the time now? Like 3 p.m. OSPF is configured between all routers, right? Okay. After some time, it's been 3 o'clock 40 minutes p.m. No changes in network topology. Do you have updates? It's been 10 minutes now. No changes. Any updates? It's been 20 minutes now. No changes. Any updates? No. It's been 30 minutes. No changes. Any updates? Yes, we have updates. That we call here, you can see the last point. LSAs are additionally refreshed every 30 minutes. So how this exactly happening? What information they are exchanging? So then actually they are not exchanging the information. Let me explain clearly what happened after 30 minutes. What happening after 30 minutes? Now R1 router, R2 router, two routers, ISP between two routers. R1 have configured OSPF and R2 have configured OSPF. Now R1 blindly directly will exchange the database with two neighbor. Is it right, guys? OSPF, once you configure OSPF directly will send information. No, then what OSPF will do? Before exchanging database information, now R1 will come to know R2 is active or not. Neighbor is going to form the neighbor. Is going to form the disk of the neighbors by exchanging what? Hello packets. So the first packet in OSPF is a hello packet. So this hello packet mechanism for every 10 minutes to maintain the neighbor is a keep alive mechanism. Now R1, R2 hellos are exchanged. Now hellos is matching. Now R1, R2 become what? Now once AdSense is being formed, now what R1, R2 big R2 will do? Okay, once neighbor come AdSense is being formed, what exchange? Database exchange, right? So that packet we call DBD. The first one is hello packet. The second one is a DBD packet. Database DB. Database description. DBD packet. Now DBD packet is being done. Enough. No exchange, no information. Like after 30 minutes, what R1 is doing is, so our network is been 30 minutes, like R1 is going to send the information to R2. What R2 is doing, sending one packet to R2. Hello R2, do you have any new updates? He's asking the question actually. So to ask the question, is sending one packet called LSR packet. Link state request. Is asking the request. We're sending one request. Hello router 2, do you have any new updates? Link state request. Now what R2 is doing is going to reply, that is LSU. LSU. Link state update. It's giving update information. So once LSU packet is being exchanged, now again R1 will send one more packet to R2, that is link state acknowledgement, LSACK. So these all are OSPF packets. Hello packet, DBD packet, LSR packet, LSU packet, LSACK. Hello packets are for every 10 seconds. Sorry, I have minutes. Sorry. Every 10 seconds for to maintain the neighbor, and DBD packet are being exchanged once the distance is being formed. So, but this LSR, LSU, LSCK, this is happening after 30 minutes. For every 30 minutes, they are doing this process. Any new update? Give me update. And thanks for update information. These all are OSPF packet types. In interview, they can ask you question is like, can you please tell me about OSPF packet types? Yes, we can need to tell about. So OSPF packets are hello packet to maintain the neighbor, to discover the neighbor, is keep alive mechanism, and DBD packet, which is database information. Once neighbor is been formed, the database information is been exchanged. The remaining packets are after 30 minutes, which is LSR. Is asking the question for the update link state request, and LSU and LSACK link state acknowledgement. These all are OSPF packets. Okay, guys. Here. Hello packet, DBD, LSR, LSU, LSACK. You can copy it now. Copy it here. Right. So these are about OSPF. Now we discuss clearly about what is OSPF area. OSPF area concept. thinking about this diagram? Let me discuss on topology clearly now. Okay, let me explain it. Let me explain it clearly. The OSP of majorly, you think broadly in real time. OSP support for very good advantage we have, right? And OSP of advantage are what incremental updates. It has less bandwidth. It is not reaching the must bandwidth like RIP protocol. It find the best path. Yes, unlimited hop counts is a very good advantage. It find the best path based upon the cost and supporting the load balancing, is maintain the neighbor and neighbor tables. It's a very good protocol. So real time also we use what? OSP. Very large organization. If we take our regular example, large organization is what in banking sectors, SBI. In overall India wide, how many branches are available in India for SBI? Let's example, 14,000 branches. Okay. Now for all 14,000 branches, routers to enable communication, which protocol is recommended is what? OSPF. So as we already early discussed, for 14,000 branches are connected in a different areas. Small banks like a very small office and a medium office and large companies, the rural area banks and urban area banks, like based upon the requirement, Cisco has a different categories of router, right? You remember in introduction to router, we clearly discussed 2600 router, 2800 router, 6000, 5000, right? So what was the difference between 2600 router and 5000 series router, 9000 series router? The 2600 router series speed is it can be Ethernet port or it can be a fast Ethernet. Like fast Ethernet series router, it can be fast Ethernet, it can be gigabit. For 9000 series router, we already seen like a 10 gig, 20 gig, 40 gig, 80 gig like this there, right? Not only speed wise, like internally, NV RAM size, your memory size, very low memory and low processor speed. For 5000 series router, maybe high-end core router, high processors, and very high RAM power and NVRAM size, very high size, right? And for 9000 series and processor, multiple number of processors, very high-end core processors, and router performance is very high-end performance. All the major differences. So these all are head office main. Let's say this is my core router, SBI core. From core router, head office are connected. Head office are connected. Now from head offices, HO1, HO2, HO3. From head offices, your branches, small branches are connected. Branch 1, branch 2, branch 4, 5, 7, number of branches. Example, total how many branches? 14,000 routers. So complete this topology, which routing protocol is recommended means what? OSPF. In 14,000 routers, you have configured OSPF. Now you tell me guys, OSPF process. What was the OSPF process? 7 states. Do you remember? First one is what? In 14,000 routers, first state is a down state and second is a initial. They're exchanging router IDs and third state is what? Two-way. Hellos are exchanged. Like start, exchange, loading, full. So OSPF is a link state protocol. Link state protocol is telling is that with respect to each router should maintain full picture of the topology. So SBI core router means here we are recommended is a 9000 series router. For head office or which series router like 5500 or 5000 series router. If all are branch offices, like for branch office routers, which model numbers do you recommend, guys? 2600 or 2800, right? Okay. Okay. Now, what OSPF is telling is that if you configure between the 14,000 routers OSPF with respect to each router should maintain full picture of the topology, right? The core router is a 9000 series router means it has a very high memory, a high processor. It can be maintained 14,000 links information, 14,000 routers information, database information can be maintained. But your branch office router also. Your branch office 2600 router also should maintain how many routers links information. With respect to each router should maintain in entire view, right? So even your branch router also 14K routers links information, 14,000 routers information should maintain. Like when your branch router is maintaining the 14,000 router links information, what about your router performance, branch router performance? Down, slow. A complete all branches will be go down. So what branch routers is sending is update to head office router is hello head office router. We are like my routing table is a too big. We are running out of memory. My routing table is a too big. It's sending update every time. My routing table is too big. My routing table is too big. So many updates is coming to head office router. Head office will update to core router. And again going to algorithm is repeating. So it makes, you know what happened here? Complete your 14,000 router performance also will be down. That means complete SBI network is slow. The customers, no customers for SBI. We shifted to like any other banks. This is the happening problem. So here, then what is the solution here? Solution number one. Solution number one is solution number one is even branch router also we need to install 9,000. Even head office also we need to maintain 9,000. Like complete your SBI. Like all routers should maintain 9,000 series. Now they can maintain, right? Now can maintain 14,000 routers information. No problem, right? This is the first solution. Is it best solution? Why? Very high expensive. Like 9,000 series router, let's say example only for 1 CR. Like how many branches in SBI? 14,000. Like your banks in a like village in a rural area, they are only 10 to like 100 customers. Very slow traffic. But even we need to maintain 1 CR router, right? The bank also there is no depositor for 1 crore rupees, but you need to maintain router 1 crore rupees router. Again, to configure 1 crore like high-end router, we need to appoint one network specialist. And from security also, 1 crore rupees router, we require security also. Every time we need to maintain one security guard here. The problem actually. It's not recommended. Not recommended. But hierarchy design is what? Head office 5,000, branch office 26,000. And core is 9,000. Like if you maintain like this, problem is what? Your branch routers are running out of memory. Routing table is too big. That is the reason. No, these all 14,000 routers will comes to one group. That group is what? SBI group, right? Like all 14,000 routers belongs to one group. So this logical group we called area. So area means number of routers will comes under one group called what? Area. For SBI area 14,000. If you go for HDFC area, this is maybe like a 5,000, right? Like that. The number of routers will comes under one administrator or one group we call area. Logical boundary. So that default area is a 0. In area 0, how many routers are available, guys, here? 14,000 routers. So with respect to each router should maintain how many routers information? 14,000 router information. But if you maintain 14,000 routers information is running out of memory, routing table is too big. To avoid this type of issue, OSPF recommends, OSPF introduced area concept. Like what area OSPF is doing is a single area 0 is being divided into multiple areas. So we have design like that. Let me design like this here. These routers have configured area number 10. In area number 10, how many routers are available? R1, R2, R3. So within the area means R1 should maintain within the area routers information only. No need to maintain respect of reminding all 14,000 routers information. If there is no area 10, now all routers belongs to what? Area 0, 14,000. Now again, one more area I'm designing. Here, R4, R5, R6. Like this is area number 20. In area 20, how many routers are available? 3. So with respect to each router, how many routers links information to maintain? Only 3. But before dividing areas, how many routers they need to maintain? 14K out of memory. But now only 3 routers. Like I am designing here 3 routers in one area. But total how many routers is there? 14,000. Means how many areas will you design? How many areas will you divide it? Instead of that, one area. Recommended 42 T routers. We can keep it. So there is no burden actually. We can easily maintain 40 to 50 routers, even your branched router also. So for each area means area 10, we can have how many routers? 40 to 50 we can configure. In area 20, 40 to 50. Area 30, area 40, area like some. Each area should be what? 40 to 50 routers you can maintain.
Sir, one question.
Yes, please.
Sir, in each area, let's say area 10, there are 3 routers, right? So head office, one router also it comes under area 10?
Yeah, let me explain that also. I'm coming for that also.
Okay.
Area 30. So area 10, area 20, area 30, area 40, area 50, like number of areas. A number, you know what? One area 1 to 65, 65,535 between any number, you can use it. Area number. Here we have some conditions is there. You know, the condition is area 10, area 20, 30, 40, not. You can divide multiple areas, but one should be backbone area. Like without backbone area, we cannot divide the multiple areas. One should be backbone. So that backbone area is a area 0. So let me make a core router is a area 0. Area 0. Like after area 0, now we can divide area 10, area 20, area 30, 40 number of areas. Yeah. Even area 0 also you can have what? 40 to 50 routers. Not only one router in area 0, 40 to 50 routers. Come to here, issues with Ospf single area. By default, all belongs to area 0. See the head routers are doing is what? I'm running out of memory because my routing table is too big. I'm receiving too many LSAs, too many updates. I want to run some number of times in the algorithm. So this happening here makes your complete network performance is down. Then what OSPF is doing is OSPF network design is divided into multiple areas. One area has to be the designated as what? Area 0. That area we call backbone area. Remaining all areas are what? Non-backbone area. Here guys. Now we'll come to here. The core router, SBI router. Core router is a which area? Area 0. Area 0 we called what? Backbone area. Area 0 is what? Backbone. Backbone area. Remaining area 10, area 20, 30, remaining all what? Other than backbone area. Remaining all what? Non-backbone areas. Now let me discuss clearly router types, OSPF router types. Router which belongs to area 0. Repeat. Router is which belongs to area 0. That routers we call backbone routers. BR, backbone router. So backbone routers can be a 40 to 50 routers. Like in area 0, can be what? 40 to 50 routers. Do you think in SBI maintain like SBI has a 14,000 routers should be maintained by only one core router? No. Area 0 should be what? 40 to 50. But router which belongs to area 0, router which belongs to backbone area, that router we call what? BR, backbone router. Now router which belongs to regular area, I mean area 10, area 20, area 30. So router which belongs to regular areas, these routers we call IR, internal routers. Area 10 routers, area 20 routers, all routers are regular areas. Regular area we call internal routers, right? Now, what about head office routers? As by Minhas is asking question, right? Now, let me come to that question. What about head office routers? Here, one question you can ask me, like how Balu R1 is maintained only within the router since information only, then how R1 can communicate with other areas routers? How R1 can come to area 10, area 30 routers? Like how 14,000 routers can communicate? But R1 is not maintaining the other routers information, right? Within the area only your maintenance information, then how communication enabled? That is the main logic. So within the area routers, what is doing is these links information will update to head office router. Head office will update to core router. Now core router is it can maintain all routers information, right? It's a very high power, high memory, right? So core router can maintain what? 14,000 information only. All information. So the question is here, head office routers belongs to which area? So router which connecting two different areas. The head office belongs to area 0 as well as what? Area 10. a router which connecting to different areas. That router we call ABR, area border router. Even head office is connecting area 0 as well as area 20. Head office area 0 as well as what? Area 30. So these all routers are area border routers, ABR router. So IR is going to update to ABR, ABR is going to update to what? BR, backbone router. Okay, Minas. Clear now? The router which belongs to backbone area. The router we call what? Backbone router. Router which belongs to regular area. The router we call what? Internal router. Router which belongs to two different areas. Router which connecting to different areas. That router we call what? Area border router, ABR. Okay. Area 0. Area 0 router we call what? BR. Backbone router is connecting area 0 as well as what? Area 1 is ABR. Is also area 0 and area 2 is the ABR router. And internally IR router, IR. All are internal router. Okay. So types of routers. Backbone router, BR, belongs to backbone area. IR, internal router, which belongs to regular area. ABR, which shares to different areas. And ASBR, autonomous system border router, which is connected to different protocols. So this ASBR will comes under CCNP level classes. I can skip it now here. So let me clearly discuss about what BR, IR, and ABR are. But just keep in mind, ASBR also what will do? It's connected to different protocols.
Sir, one question about ASBR.
Yes, please.
It is connected to different protocol means normally we have OSPF, right? If we are going like international connecting between two different regions or cities or countries, does that mean that we have different protocols at that levels and that's when ASBR comes into picture? Just a little overview, sir.
In R1 router, R2 and R3, in R1 have configured RIP, in R2 have configured OSPF, in R3 have configured AICR. Three routers are connected. Now R1, R3 can communicate. R1, R3 can communicate. No. R1, R2 can communicate. Why? Because three different protocols, right? So in R2, if I configure redistribution, so what R2 is doing is, when the traffic is coming from R1, RIP traffic is being redistributed to EHRP traffic. When EHRP traffic is coming, EHRP traffic is being redistributed to RIP. So means in R2 router, how many routing protocols is running here? RIP, OSPF, EHRP. That's the point here. Router which is connected to different protocols. So in this scenario, R2 router is connecting to different protocols, right? So this router we call what? ASBR router. Autonomous system border router. Where redistribution is being configured, that router we call ASB router. A single short form, we can simply say where redistribution is being configured, that is what ASB. Core router can be maintained. VR router will maintain all the routers information. Yeah. Let me type the points first clearly and we'll discuss. All about OSPF from today's we clearly discussed. What are the points we have discussed is here starting between IP and OSPF we have discussed clearly. The next OSPF characteristics. OSPF router ID, OSPF 7 states. Neighbor, what is neighbor and what is adjacency and OSPF tables and hello packet contains information. OSPF metric calculations, OSPF wildcard mask and LSAs, packet type, single area, multiple area, router types is all the OSPF terminology. Right? Let me repeat once again. OSPF characteristics. OSPF is a open standard. OSPF is open standard or only the Cisco protocol? Is all of you open your chart box and reply? OSPF is an open standard, can support for what? Multiple vendors. Is a classless routing protocol, support for subnetting. And OSPF will send the multicast hello packets by using which IP address? 224.0.0.5. Okay. And administrative distance of OSPF. 110. Okay. OSPF router ID. OSPF router ID is used to identify the router in OSPF network. And first preferences for router ID command and second preference for highest loopback interface IP address and third prior default preference for highest physical interface IP. OSPF 7 states, down state, initial, two-way, start, exchange, loading, and full. Neighbor, directly connected device called neighbor. From the neighbor, to maintain the neighbor, hellos are being exchanged by matching hello package. Adjacency will be formed. So to match, what should match in the hello package? Area ID should match. Network ID should match. Subnet mask, hello timers, dead timers, authentication. Once hello packet is been matching, then successfully neighbors be called adjacencies. Adjacency database data exchange. Right? And OSPF maintains three tables, which we call neighbor table, database table, and routing table. OSPF neighbor table contains directly connected neighbors by forming adjacency. And OSPF database table contains entire view of the topology, like all possible routes. Right? And OSPF routing table contains best route, best path information. And OSPF metric calculation. OSPF metric is cost. Cost has been calculated by using formula called reference bandwidth by interface bandwidth. OSPF default reference bandwidth is 100 Mbps. So by using that formula, we clearly calculated about cost values of Ethernet and fast and serial ports. OSPF Ethernet cost value is what? Fast Ethernet cost 1. Serial interface cost 64. Based upon the cost values, we can define, right? That's the metric calculation, and we can change also cost values. If cost is same for all the links, then what OSPF will do? Load balancing. Good. And OSPF wildcard mask. What was the formula wildcard mask to calculate? Global subnet mask minus subnet mask. In short form, we can say inverse of subnet mask is what? Wildcard. Okay. LSA, link state advertisements, incremental updates. When there is change in topology, then only update, which is a quick update. And OSPF packet types. Hello packet, DVD packet, LSU, sorry, LSR, and then LSU, and then LSACK. Welcome mask, okay, and single area. What are the issues of single area? That all branches are running out of memory because routing table is too big. To avoid this type of issues, OSPF hierarchy design single area into multiple areas. So when you're designing multiple areas, one should be backbone area. The backbone area router we call BR. OSPF router types are what? Backbone router, area border router, internal router, ASBR router, autonomous system border router, right? So these completely OSPF stuff. You try to more concentration on these topics. You go for interview. From these points only, they can ask the questions. And for a Cisco exam also, you can get them from these topics. The list only, okay? You try to get the more information from this concept. Okay, guys. The next tomorrow is Sunday. That's for today.